Greetings to all of you. In this session, we are going to discuss about international, national and state level chemistry and pertaining intermediate entrance examination and also helpful for competitive exams. So this is helpful for JEE mains, advanced NEET examination, TSMCET, APMCET, and other entrance examinations as well. And competitive exams also, it will be very much helpful. Let's go with the question number one. One of the essential mineral in the human body is salt. How much salt, sodium chloride, is in the average adult human body? If you consider the human being, in that human being, the salt content will be there in the form of electrolytes. So many different minerals are available. Among all, the most common one is sodium chloride. That is the table salt what we are using daily. And how much content of this sodium chloride is present in adult human body, we have to predict. So here options are provided: 1 kilogram, 500 grams, 250 grams, and practically not possible to predict. From these options, we have to find out which is the right answer. So in general, human body contains so many type of salts, especially sodium chloride is the commonly available one. Among all these, major one is called a sodium chloride only. Whatever your body weight is there, in that 0.4 percentage body weight is accompanied by this salt content. For example, if human being is of 50 kilograms of the weight, and if 50 kilograms are there, then 200 grams of sodium chloride will be present. 200 grams exactly is equal to 40 tablespoons. In this regard, if we consider 50 or 55 of the adult human weight, then 250 grams is the commonly available salt content in the human being. So option C will be the right answer for the question, how much content of sodium chloride will be there in the adult human. So 250 grams is the right answer. Let's see in what way salt will helpful for the various process in the human being. Whenever salt administered into the body and salt content which is present in the body in the form of electrolytes, that will helpful for the blood sugar control. So here sugar levels will be properly controlled by the salt content. Okay, so sugar levels or glucose levels will be controlled by this one. And optimal muscular and nerve function. In order to properly function the muscles as well as nervous system, the exact amount of salt is very essential. Another important thing is blood pressure control. So BP is maybe of high pressure or low pressure. High BP and low BP are present. So this is purely due to pumping of blood in the veins. So whenever salt content in the optimum level, blood pressure levels also regulated in a proper way. So salt content directly related with the blood pressure. So we have to make the optimum level of salt in the human body. Another is about helps to maintain the stomach pH. Our stomach will secrete the acid in order to digest the food. It works like a catalyst. In order to maintain the pH as a neutral, the sodium will neutralize the excess amount if hydrochloric acid secreted in the stomach. So this also will be the application of the salt in a human stomach. In either by maintaining the optimal level of the electrolyte, especially sodium chloride, and it used to maintain the balance in the body. So electrolyte balance is also possible, which used to give the harmonical functioning of all the organs in the human being. In either healthy metabolism. So metabolism stands for the kind of activities whatever carried in the human being in the daily routine, all pertaining to human metabolism, that will be perfectly balanced by means of administrating this salt. So that salt content a regular level, that is 0.4% is the required level for the healthy human, so that we can regulate all these kind of activities by means of the regulating salt levels in the human being. Let's move on to the question number 2. If you fill a glass to the brim, means up to the top level, with ice water and ice melts, what will happen? Whenever ice melts, what kind of consequences we will face if ice is melting? So let's see what options are provided. The glass will overflow as the ice turns to water. The level of water in the glass will remain unchanged whenever ice melts. The water level will drop slightly as the ice melts. I will never find out because I will drink the water and walk away before anything happens. The right answer will be water level will drop slightly as the ice melts. What could be the reason behind this is, so usually whenever different phases of matter are considered, solid will have higher density when compared to the liquid. But exceptionally, water is a peculiar compound where you can find the maximum density of liquid water rather than the solid ice. That's the reason why. So if you go to the polar region, so most of the top region covered with the ice and the bottom level beneath the ice layer, you can find the water level, which is the source of survival of the aquatic species. And if you take the ice cubes and pour into the water, so that these ice cubes will float on the surface of water, that is because of less density. Whenever ice is melting, so that is becoming less density to higher density, so that it decreases its volume, right? So whenever ice is there, so that is clearly explained by taking example. Take the bottle of water and place in the deep freeze or freezer, and wait for 2 hours or 3 hours. If you are going to fill up to certain level only, what happens, that entire bottle of water will become solid and you will get the ice inside the bottle. For example, if the same bottle is filled up to the neck, so completely filled without any air gap, you are going to fill this bottle with a complete water. In that condition, if that bottle placed in the freezer, after 3 hours, if you observe, you can find the cracks in the surface of this bottle. That is because of whenever water turned into ice, its volume got expanded. Whenever volume expanded, bottle is not sufficient to occupy because already it is completely filled, no, with water. Whenever it turned into ice, it need more volume. In order to get the more volume, cracks are generated on the surface of water bottle. That's the reason why here, as liquid to solid formation, its volume occupation got increased, so that solid to liquid formation, volume occupied got decreased because it is having maximum density in the liquid form. This is the right option. Option number C is the correct answer. Let's move on to another question, question number 3, which is given in the JEE Advanced in a chemistry. SO2Cl2 is on reaction with the excess of water results in the acidic mixture. SO2Cl2, when taken and added with hydrated water, the formation of products are, one is sulfuric acid and other is hydrochloric acid. The question is, if 16 moles of sodium chloride is required for complete neutralization for the resultant acidic mixture, number of moles of SO2Cl2 used are, how many moles of SO2Cl2 used here? That we have to predict. The correct option will be option number C. 4 moles is the right answer. Let's see how it is possible to get this. Here is the relation. Equation is already provided to you. SO2Cl2 upon hydration gives rise to mixture of two acids. One is called sulfuric acid, another is called the hydrochloric acid, right? So whenever you're treating the products with the sodium hydroxide is the base and the products are purely acid. This is a kind of neutralization. In order to neutralize these acids, we are consuming 16 moles of sodium hydroxide. That is nothing but 16 H plus ions consumed for the neutralization. It's very clear. Now, if you observe this equation, SO2Cl2, 1 mole consumed. But here, if you see H plus ions, in sulfuric acid 2 hydrogens, in hydrochloric acid 2 H plus are there. Totally 4 H plus got generated. That is nothing but one of the SO2Cl2 mole used to generate 4 moles of H plus ions. That is the relation. That is same represented over here. 1 mole of SO2Cl2 produces 4 moles of H plus. If 16 moles of H plus are there, how many moles of SO2Cl2 are required? You have to go for cross multiplication. So here 1 mole into 16 moles divided with the 4 moles of H plus. 1 into 16, 16 itself divided with the 4. 16 divided with the 4 is nothing but 4 moles. This is the way to solve the problem if it is given. It is an indirect way of solving the problem. So we are not directly predicting what sodium hydroxide is doing. It is doing neutralization of this one. One sodium hydroxide neutralizes one H plus. Here 16 sodium hydroxides are used to neutralize 16 H plus. So that 16 H plus if present, then how many SO2Cl2 should be used for the reaction? That we have to go for cross multiplication. Let's move on to question number 4. It is the question given from atomic structure. Which of the following set of quantum numbers are not allowed? You already aware that quantum numbers are 4. One is called a principal quantum number. Second is called azimuthal quantum number, which is also called as angular quantum number. Third is known as magnetic quantum number, and fourth is called as spin quantum number. There is a relation between one to any other quantum numbers. Principal quantum number gives the shell and the energy of the orbital, and always it is accompanied with 1, 2, 3 like that, or else K, L, M, N like that. Okay. And the second is about L, called the angular quantum number, which gives the dimensions of the orbitals, and whose value always resides as n minus 1 value. It may not be equals to principal, rather it may not be greater than the principal quantum number. Always it should be 1 less than the principal quantum number. That is the fundamental you have to follow. And in either magnetic quantum number, it will give the orientation of the orbitals, and always magnetic quantum number values lies between minus L, 0 and plus L, right? So that is the way we have to represent magnetic quantum number. And the spin quantum number, how the electron is spinning, if it is moving in right hand direction, called clockwise, which is given with the plus half, anti-clockwise minus half value. Only two options will be given for spin, plus half or minus half. That's it, right? So from these four options, we have to predict which set of quantum numbers are not allowed. We already aware. So in all the cases, principal quantum number is provided with 3 only, so that it is the third main shell. And if you see L value is 2 is the right answer, because n minus 1, n is a 3, 3 minus 1 will become 2. This is the right combination. So 0 is also valuable magnetic quantum number, because if L values are 2, M value will become minus 2, minus 1, 0, plus 1, plus 2. So that 0 is possible. S value either positive half or negative half. Here it is given with positive half, so that A is completely allowed kind of combination. Go with B. B, n is equal to 3, that is principal quantum number. Angular quantum number 2 is also right combination. M, magnetic quantum number, is given by minus 2. Minus 2 is also valuable, because L value is 2, M value lays between minus 2, minus 1, 0, plus 1, plus 2. So that minus 2 is allowed. Plus half is also allowed. In option number C, n is equal to 3 is the principal quantum number. L is equal to 3. N is equal to 3. L is equal to 3 is not applicable, because always L value must be in minus 1. So that combination of option C is not at all possible. This is not allowed. Let's see. N is the principal quantum number. L is the azimuthal quantum number. M is the magnetic quantum number. S is the spin quantum number. The values are given here. Always principal quantum number 1, 2, 3 can be a representation. Azimuthal will be 0, started with 0 and lays in between n minus 1 values. Always magnetic will be minus L, 0, and plus L will be their values. Spin will be always plus or minus half. Here option number C is not at all possible, where L value must not be 3. It should be 0, 1, 2 only. This is the right answer. Let's go with the question number 5. Which of the following is called disproportionation? So many reactions, 4 reactions are provided. We have to identify how many reactions comes under disproportionation. Before going to see the options, first of all, we have to know which are called disproportionation reactions. The reaction in which Single compound will participate in oxidation and reduction simultaneously. That reaction is called a disproportionation. For example, if you take chlorine, if it is converted into negative one as well as positive one, so that chlorine 0 is converted into negative one in one compound, positive one in another compound, so that simultaneous oxidation reduction possible for same compound, that is called disproportionation. Okay, in one of the compound its oxidation state around the central compound will be raised, in another compound, oxidation state around the central compound will be lowered. That combination we have to predict. If you go with option number A, chlorine with NaOH, NaCl, NaOCl and H2O. H2O to decomposition gives rise to water and oxygen. KMnO4 gives rise to K2MnO4 and MnO2O2. MnO4 minus 2, nothing but K2MnO4 only. 4H plus gives rise to KMnO4, MnO2 and 2H2O. Out of these four reactions, how many comes under disproportionation category? Let's predict. In order to identify disproportionation, the important step is finding their oxidation states around the central compounds. Let's go with option number A. Sodium hydroxide, always sodium will accompany with the plus 1 charge. Oxygen will be negative 2. Hydrogen will be positive 1. Chlorine always having zero oxidation state around the central chlorine. Sodium chloride, if you observe, sodium is having plus 1 only, but chlorine is having minus 1. If you see chlorine in the reactant, it will be 0, and in the product, it is becoming minus 1. 0 to minus 1 is the kind of decrease in the oxidation state around the central chlorine. Decreasing the oxidation state of any material around the central compound is called a reduction. And in another compound, NeClO, you can find the chlorine with the plus 1 oxidation state around the central chlorine. So that 0 to plus 1 is called rise in the oxidation state around the central chlorine, which is called a oxidation. Chlorine 0 turned into minus 1 and plus 1 as well, so that it is a kind of disproportionation. Oxidation, reduction, both are possible. Go with option number B, decomposition of hydrogen peroxide. In hydrogen peroxide, you can find the H2O2 having open book model type of geometry, and oxygen always in hydrogen peroxide accompanied with the negative 1 oxidation state around the central oxygen, and upon decomposition turned into water where oxygen is having minus 2. Minus 1 turned into minus 2 is called a decrease in the oxidation state around the central oxygen, and O2 is the gaseous molecule where minus 1 turned into 0. It is the kind of increase. Minus 1 to 0 is called increase in the oxidation state around the central compound. So that in one way reduced, in another way oxidized, and this is also the part of disproportionation. Let's go with C. KMnO4 where manganese is having plus 7. In K2MnO4 manganese is having plus 6. MnO4 where manganese is having MnO2 manganese is having plus 4. So that plus 7 turned into plus 6 decrease. Plus 7 turned into plus 4 again decrease. Decrease, not yet all comes under disproportionation. So that option C is the not the part of disproportionation reaction. Let's go with option number D, K2MnO4, where manganese having plus 6. In the product KMnO4 plus 7. Plus 6 to plus 7, so that rise in the oxidation state around the central manganese, which is called oxidation. In MnO2, manganese accompanied with the plus 4. Plus 6 to plus 4, this is a decrease in the oxidation state of the central manganese called reduction. So that single compound oxidized and reduced, hence it is also the part of redox. Means disproportionation. So option number A, B and D are the part of disproportionation reaction, that A, B, D are provided in the option B. Let's go with the last question of the session. Which of the following sequence is the correct for decreasing order of ionic radius? If you observe ionic radius means size of the ion. Here, size of the ion follows the trend in different ways in the different main groups and the periods. If you come from top to bottom, gradually ionic radius will rises if same charge is there. If you come from left to right, ionic radius will be gradually decreased. If you observe all the elements whichever provided over here, iodine, selenium, bromine, oxygen and fluorine, these are the elements present in only two main groups. One is chalcogen family, second is halogen family. If you see oxygen and selenium, these are the part of chalcogen, that means oxygen family. Oxygen family elements are oxygen, sulfur, selenium, tellurium and polonium. Top to bottom size gradually increases, so that oxygen is the lesser size, selenium is the larger size. And let's go with the next, another main group called a halogen family, called a fluorine family, where elements are fluorine, chlorine, bromine, iodine or statin. So that from fluorine to iodine size gradually increases. Hence we can write iodide followed by selenide, bromide, oxide, fluoride. This will be the right order. Iodide, selenide, bromide, oxide and fluoride. Tiniest one is fluoride. Let's observe one formula, one fundamental thing whichever possible over here. Whenever any neutral element got converted into its own positive by losing electron, size will be decreased. If you observe lithium metal and loss of electron gives rise to lithium positive, whenever lithium metal to lithium positive, always the size will be lowered. Initially 152 picometers got turned into 60 picometers by the loss of electrons and converted into electropositive ion. This is one point we can remember. And second is about fluorine. Elemental fluorine is having 64 picometers. Whenever electron accepted, it will be turned into fluoride ion, so that whenever neutral element converted into its own negatively charged ion, its size drastically increases, right? So that 64 picometers turned into 136 picometers. Electropositivity will lower the size, electronegativity will rise the size of that particular element. This is the thing we have to know about. Later we will go with the trends in the ionic radii. And we already know 6th A is the family of oxygen, 7th A is the family of halogen, means a fluorine family. If you see oxygen -2, which is having 1.40, fluorine having 1.30, tiniest one, and S -2 is 1.84, not required, not given in the problem. Selenide is given Se -2, which is 1.98. This is required. Iodine is given, iodide is given, that is 2.16. Bromide is given 1.85. Chloride is not given, 1.81. Let's arrange all these elements in accordance with the increasing order. Least one will be 1.36 for fluoride. Later on, you can place oxygen oxide 1.40, and the next element comes with the bromide, that is 1.85, and selenide given with 1.98, and the highest size is given for 2.16 iodide, I minus ion. So this is the right order which is provided over here, that is the option number 1. By this we completed the entire session of explanation for the day, and I'm requesting you to like the video, comment upon this, share this video with whoever require, whoever aspirants for this intermediate competitive exams as well as any entrance examinations, and subscribe the channel. And I'm very much thankful for watching uh, without any agitation. Thank you one and all. Have a great day.